ever feel like trying to keep pace with all the advancements in AI, cloud computing, software engineering, system design? It's like trying to drink from a fire hose.
Oh, absolutely. It's a
It
lot.
really is, right?
Oh,
Just when you think you've kind of got a handle on something, boom, another big shift happens.
yep. And that's exactly why we're diving into the latest Beyond the Code with Prateek, the one that just dropped yesterday, April 14th, 2025.
Okay.
Think of this as your curated briefing. We've pulled out the really important stuff so you don't have to spend hours wading through it all.
Perfect. Yeah. We're here to sort of help navigate this because it moves so fast. And this latest dispatch, wow, it's packed. We're going to focus on 4 key things that really stood out. Some seriously supercharged new AI models from OpenAI, this interesting idea of AI systems where different agents work together.
Right, multi-agent systems.
Exactly. And then how these agents can actually talk to each other, a new standard for that. And finally, a neat tool to make plugging AI into web apps, like way simpler. So our mission today is pretty straightforward. Give you the essentials on these developments, why they might matter to you, without getting totally bogged down in jargon.
Let's do it, starting with OpenAI.
Yeah, let's unpack that first. They're new power players.
Okay, so OpenAI just rolled out their GPT-4.1 family. That includes the main GPT-4.1, a GPT-4.1 mini, and even a GPT-4.1 Nano.
Okay, 3 versions?
Yeah, and what's really interesting is their focus.
Yeah.
These aren't just general-purpose models. They've been specifically tuned for coding, for really following instructions accurately and handling huge amounts of context, massive amounts.
Right, and crucially, you can't just get these through the normal ChatGPT interface, can you?
No, that's a key point. They're exclusive to the OpenAI API,
Ah,
which really signals they're aimed at developers, people building things with the AI.
gotcha. And the performance improvements they're claiming, they sound pretty impressive, especially for coding.
They really are. On this benchmark called SWE Bench Verified, it's for software engineering tasks.
Yeah.
GPT 4.1 apparently beats GPT 4.1 by, let me check, yeah, over 21%.
Wow.
And it beats the older GPT 4.5 by even more, like 26.6%. That's a really noticeable jump in coding ability.
That is a big leap. And you mentioned context, handling huge amounts.
Huge. We're talking up to 1 million tokens for the context window.
Whoa, okay. 1 million tokens. What does that actually mean in practice? Like, what can you do with that?
Well, think about it. That's enough to feed it, say, the entire code base for a pretty large software project.
Yeah.
Or maybe several very long, dense technical documents all at once.
So no more breaking things up into tiny chunks.
Exactly. Imagine analyzing a whole code base for bugs, or understanding a massive report without having to feed it in pieces. You could potentially reclaim so much time.
Seriously, that idea, analyzing a whole code base in one shot, that's kind of mind-blowing. What about cost, though? Often these bigger models get expensive.
That's the other interesting part. GPT 4.1 mini is apparently around 83% cheaper than GPT 4.0.
83% cheaper.
Okay. And it has lower latency, so it's faster too. And then the Nano version for really light tasks starts at just pennies, like 10 to 40 cents per million tokens.
Wow. That kind of pricing, that could really change things, couldn't it? Make powerful AI much more accessible for smaller teams or even individual devs.
That's a crucial point, yeah. It could unlock whole new types of applications, maybe things that need to be always on, but were just too expensive before.
Mm-hmm.
And remember, these aren't just text only. They handle multimodal input to text and images.
Ah, right.
So combine that image understanding with the huge context and the better coding, you could start dreaming up some pretty complex workflows.
Okay, so let's bring it down to earth. For someone listening, if you're a developer, this might mean what? Faster code writing, better debugging?
Definitely. Significantly faster generation, maybe more accurate debugging suggestions, the ability to handle much bigger, more complex projects.
And if your job involves lots of reading, like reports.
Imagine summarizing or pulling key insights from massive documents almost instantly.
Okay. And the mini version sounds great for just trying stuff out.
Exactly. Rapid prototyping without a huge bill, test ideas quickly.
Makes sense. And if people want to dig deeper, Prateek mentioned some resources.
Yeah, the official OpenAI announcement for GPT 4.1, obviously. The API documentation is key.
Yeah.
And that SW Bench leaderboard if you really want to geek out on the performance numbers.
Got it. And things people could try now?
Well, if you haven't already, sign up for the OpenAI API. Maybe try giving GPT 4.1 mini a specific coding problem you're stuck on.
Good idea.
Or even just play with the 1M token input in the API playground. Just paste in a massive chunk of text and see what happens. It helps grasp the scale.
Feel the power.
And join the OpenAI community forum. See what others are doing. Share ideas.
Cool. Okay, so that's the new firepower from OpenAI. Now let's shift gears a bit. You mentioned multi-agent systems,
Huh?
like AI teams.
Exactly. Let's talk about Microsoft's AutoGen framework. It's open source, and it's all about building systems where multiple AI agents can collaborate by essentially having conversations.
Okay.
The latest version, 0.4, which came out in January 2025, introduced this asynchronous architecture.
Async. So things can happen in parallel, more efficient.
Precisely. Think of it like several cooks working on different parts of a meal at the same time, instead of one cook doing everything step by step. More flexible, potentially faster.
Okay, so AutoGen lets you build these AI teams where different agents work together on a task.
That's the core concept. Multi-agent chats. You might have one agent good at writing code, another good at finding information, another good at planning, and they coordinate.
Interesting. And how flexible is it? Can you customize these agents?
Very flexible. That's a big plus. You can plug in different LLMs, connect them to various external APIs to get real-world data, or perform actions.
Oh, so they can actually do things, not just talk.
Yeah, they can interact with external services,
Yeah.
and you can even weave human input into the process at different points.
Ah, so a human can be part of the team too, or oversee it.
Exactly. It makes it really adaptable for all sorts of potential uses you might be thinking about.
That ability to connect to external services, that seems key to making them actually useful in the real world.
Totally broadens the scope. And for people who aren't deep coders, they've also got AutoGen Studio.
Studio, what's that?
It's basically a no-code GUI, a graphical interface where you can drag and drop, visually set up, and prototype these multi-agent systems without writing code.
Oh, wow. Okay, that makes it much more accessible.
Definitely lowers the barrier to entry. And they also provide something called AutoGen Bench to help you test how well your agent teams are actually performing.
Right, makes sense to evaluate them. What kind of use cases are we seeing? Prateek highlighted some.
Yeah, some really compelling ones. Imagine a software dev workflow. One agent writes the code, another agent debugs it automatically, a third agent runs tests, all working together.
Okay, that sounds powerful.
Or think about customer support. Agents that can automatically pull customer history from a CRM like Salesforce to give better, faster answers.
Yeah, I could see that.
There was even a research example mentioned, a team called Magentic One, built with AutoGen. They could do complex stuff like browse the web for info and manage files locally. Shows the potential for tackling tricky problems.
So if this idea of building AI teams sounds cool, where should people look?
The main place is the Microsoft AutoGen GitHub repository. Yeah. Code, examples, everything's there.
Okay.
They have good documentation too. For the theory behind it, there's a research paper, AutoGen Next-Gen LLM Applications.
Right.
And there are video tutorials, even a whole book on multi-agent systems with AutoGen if you want a deep, deep dive.
Lots of resources. And for getting started, hands-on.
Clone the repo, try running the examples, build a simple coding assistant maybe.
Good way to learn.
Or use AutoGen Studio. Try prototyping a chatbot without any code just to get a feel for it.
Nice. And community.
There's an AutoGen Discord server, good place for questions and seeing what others are building.
Okay, cool. So we have powerful individual models and frameworks to make them collaborate. What about getting different systems of agents to talk to each other?
Ah, yes. That brings us nicely to Google's Agent-to-Agent Protocol, A2A, announced just recently, April 9th, at Google Cloud Next.
A2A. Okay, so if AutoGen is about collaboration within its own system, A2A is more like a universal translator for different agent systems.
That's a great way to put it. It's designed as an open standard for secure communication between AI agents across different platforms, different frameworks.
Open standard. That's important.
Very. It's built on standard web stuff, HTTP, JSON, so it should be widely compatible. And it already has significant industry buy-in.
Yeah.
Over 50 partners, including big names like Atlassian.
Wow. Okay, so there's real momentum behind this.
Seems like it. Suggests the industry really wants this kind of interoperability.
So the big win here for people building or using AI is you're not locked into one vendor's agent world. Agents built with, say, AutoGen could potentially talk to agents built with something else, like LangChain or maybe a Salesforce agent.
Precisely. That interoperability is the key benefit, breaking down the silos between different AI ecosystems.
How does it work, though? How does one agent know what another one can do?
They have this concept called agent cards.
Agent cards, like business cards for AIs.
Kind of, yeah. They're standardized descriptions of what an agent does, what its capabilities are. So Agent A can look at Agent B's card and say, ah, okay, you handle CRM updates. I can send you this task.
Got it. Makes sense. And it's secure.
Designed with security in mind for exchanging tasks and data.
And is it just text communication?
Nope, it supports multimodal too. Text, audio, video. So richer interactions are possible.
Okay, this sounds potentially huge. What are some examples Prateek gave of how this could play out?
Well, imagine in a company, you might have AutoGen agents managing your software builds.
Mm-hmm.
And they need to automatically update a customer record in Salesforce when a feature is deployed. A2A could enable that seamless handover between the AutoGen agent and the Salesforce agent.
Right, connecting different business processes.
Exactly. He also floated the idea of agent marketplaces, places where you could find and plug in specialized agents from different creators to build custom solutions.
Ooh, interesting. Like an app store, but for AI agent skills.
Sort of, yeah. And even cross-cloud stuff. Maybe a chatbot running on Google Cloud needs data crunched by an analytics agent on Azure. A2A could bridge that gap.
That future sounds very interconnected. Where can people learn more about A2A?
Google's put up a Google A2A GitHub repo with the specs. There's a Google developers blog post announcing it.
Okay.
Definitely check out the demo video to see it in action. And there's a research paper, A2A Protocol Analysis, for a really deep technical look.
And to get a feel for it.
Run the demo locally.
Yeah.
See how agents connect.
Okay.
Also, look at the agent card schema on GitHub. Understanding how capabilities are described is key to designing for interoperability.
Right.
And just generally keep an eye on news from Google Cloud next. This seems like an area they'll be pushing.
Makes sense. All right, one more area to cover. This is about making it easier to actually use AI within our existing web applications. That can still be a bit tricky, right?
Absolutely. Connecting the AI smarts to the web front-end or back-end APIs, that integration piece is often a hurdle. And that's where FastAPI MCP comes in. It's a tool from a company called Data Inc.
Okay, FastAPI MCP. What does it do?
So if you use FastAPI, the popular Python web framework,
Yeah.
this tool basically takes your existing API endpoints
Yeah.
and automatically exposes them in a way that AI models or clients can easily understand and use, specifically using something called the Model Context Protocol, or MCP.
Automatically, you don't have to rewrite things.
That's the killer feature. They say it's zero config.
Hero config, music to a developer's ears.
Right. You basically install it, point it at your FastAPI app, and it discovers your endpoints and makes them available as MCP tools.
Wow, okay, so it bridges that gap between your web framework and AI tools, like
Yeah.
Claude Desktop was mentioned.
Exactly. It allows clients like Claude Desktop to easily interact with the functions already built into your web app via those endpoints.
And does it mess up your existing API docs, like Swagger?
Nope. That's another good point. It preserves your Swagger UI documentation so everything stays clear for human developers too.
Nice. Flexible deployment?
Yeah, you can either mount it onto an existing FastAPI app or run it standalone. Depends on your setup.
So practical uses. How might someone listening use this?
Well, Prateek suggested a few. You could easily serve up an LLM-powered endpoint, maybe for sentiment analysis, directly from your existing web app structure.
Okay, without building a whole separate AI service.
Right. Or you could link your FastAPI app functions to AI agents, maybe those AutoGen agents we talked about, so they can trigger actions in your web app.
Ah, connecting the dots.
And it sounds fantastic for rapid prototyping. If you want to quickly build an MVP, a minimum viable product that has some AI feature powered by your backend, this could make it much, much faster.
Yeah, that sounds incredibly useful for just experimenting and getting AI features out quickly. Where do people find this?
It's on GitHub, the data.org FastAPI MCP.
Okay.
They've got examples in examples directory there. There's also a community, MC Party, on Slack for help, and a setup guide video too.
And getting started sounds easy.
Seems like it. The simplest way is just pip install FastAPI MCP.
Pip install FastAPI MCP. Can't get much easier than that.
Pretty much. It really focuses on lowering that friction for web devs wanting to add AI.
Well, okay then. We've covered a lot of ground here, diving into this latest beyond the code.
We certainly have.
From OpenAI's GPT 4.1 boosting coding and context, to Microsoft's AutoGen enabling these collaborative AI teams.
Right.
Then Google's A2A aiming to get all these different agents talking to each other.
Yeah, the interoperability piece.
And finally, FastAPI MCP simplifying how you actually plug AI into your web apps.
It's a snapshot of really rapid innovation across the board.
Absolutely. It's clear things are moving incredibly fast. And these tools and protocols could really change how you, listening right now, build things or even just interact with tech day to day.
Indeed. And maybe a final thought to leave people with. As these agents get smarter, more collaborative, more interconnected, thanks to things like A2A, what does that really mean for how we design software in the future? what new kinds of systems become possible, and maybe what new challenges or complexities pop up that we haven't even thought of yet.
Yeah. That's a big question. Definitely something to chew on as you explore these tools yourself. A fascinating place to be right now.